Okay, good. Right. First thing, you got questions, ask them. Don't be afraid, you know, I won't bite your head off, certainly not at this distance. There's lots of documentation, which I can show people. And if you go down there, documentation all over the place. Right. So we're doing it because of the open call coming up in September. Deadline 1st September, 12 UTC. So not local time. L-band is an option, and as a shared risk option, we can do UHF observations as well. A shared risk means that if something goes wrong, we'll try our best, but that's it. Right.
Just a quick question, Tony.
Yeah, sure.
Hello? Yeah. For UHF, can you see the entire band? Or, I mean, I saw on the document it's a bit unclear. Can you see the entire 5 feet?
You have to drop off the bottom bit and the top bit because that's where the band rollover happens. It's the same with L-band. But UHF is actually, in general, cleaner than L-band because there aren't so many satellites going around annoying you.
Okay, interesting. Okay, thank you. Yeah.
Right. So, stuff we can do. Synchrotron emission from Jupiter, yeah, a bit unusual, but unusual stars like X-ray binaries, flare stars, supernovae, yada yada. Supernova remnants, normal galaxies nearby, galaxy clusters, even in the zone of avoidance, like the South Pole Wall. I don't know if anybody's actually asked for that yet. Oh. AGNs out to very large redshifts. Star-forming galaxies up to fairly far out. And then radio loud and some radio quiet quasars. Right. The call. Anybody, including PhD students and postdocs, can ask. Up to 100 hours in total. If you need more for your project, you have to do a pilot study first and show that you can reduce that. If you want anything non-standard, you'll need to consult with us, and you need to show that you can reduce the data. And like it says, don't be afraid to ask. Just don't leave it to the last minute. Yeah, MeerKAT proposals at ska.ac.za. Right. Bear in mind, your source may have already been observed, in which case it'll be in the archive. You can request the archive data, or you have to wait until it's released, because if it's part of a project which runs, you have to wait till the last series, last observation in that project has finished, and then wait some. Alternatively, ask people if you can have it. If your source is part of one of the large survey projects, they have prior rights, so you'll have to ask them. But if your source is bright, you don't need a full track on it. Snapshots are possible and very much easier to schedule. Right.
Hi, Tony. So if the source which I'm interested in is in the previous project, not large-scale project, but those individual projects which have their PI name and such, and should I just contact them for some sort of data sharing or collaboration?
I would advise it, yes.
Okay, I see. Thank you. Yeah.
I mean, it does become available after a certain time anyway, but you'll certainly get it a lot quicker if they've already said, okay.
Yeah, thanks. Yeah.
Right. So what if you've got an idea for an observation? Well, first, get the science justification in order, right? You go to the website and follow the links. And that's the science.ska.ac.za MeerKAT. Right. And follow the links. Right. And it's got the listing of the call for proposals, which I'm not going to go through, but a few points. It says it here very explicitly, anyone can ask, but there are limitations. You can't ask for too much. However, you can ask for target of opportunity stuff. If you want something non-standard, we will have to see about whether that's possible or not. They'll have to discuss plans. Anyone wanting such non-standard stuff have to ask it in advance to see whether it's possible. Right. You'll need to get an account to actually use anything. So if you're going to submit, if you're going to use the planning tool, if you want to go through the archive, you need an account. And that you can register with this registration page. So go to the, yeah. Yes? Any of these should get you there. Right. Bit of technical stuff. Right. No, don't do that. The specifications. Right, we've got a 64 Gregorian offset parabole. Dish diameter is normally 13.5. Well, obviously it's wider. So it's longer than it is wide. Minimum baseline 29 meters. Maximum baseline 7.7 kilometers. And it says Alan Carew. And it gives the frequency ranges there. Wideband coarse is one option. Wideband fine is another. But of course, 4,000 channels is a lot less than 32,000 channels. Well, I can actually show you. Where's it gone? In the PDF somewhere. Oh, no, never mind it. Hide it somewhere else as well. Yeah. Where's it gone? Was he in there? Wasn't there? Never mind, I'll find it. Interference is a problem. Everybody's got satellites. And that's the sorry story of the lot. So down at the bottom of L-band and up near the top of UHF, we've got mobile phones. They're not too bad, but yeah. Aircraft transponders, they're mostly off at night. But GPS, GLONASS, Galileo, Iridium, Inmarsat are always on. So beware. And here it goes through the quiet bits and the not so quiet bits. And it gives you an idea of time dependence. And if I go through the night time's here, very quiet in the aircraft band. And of course it starts up in the morning when everybody gets on their aeroplane to fly to Joburg. And as you might expect, it's a worse problem on the shorter baselines. The sun is also, of course, a source of interference, although if you're a solar physicist, I suppose it's not really. This is most of a problem in the lower frequencies and sunrise, sunset sort of time. Right, I'm not going to go through all that. It's a list of known issues. And I'm not going to go through all those as well. But there are direction-dependent effects, ionospheric effects, solar interference mentioned, and dips in the bandpass every 64 channels for some setups. We're actually trying to fix those at the moment. But it does seem to calibrate out pretty well. So not a big deal. Because the data comes in large amounts, we had to set up a pipeline to actually use it. You can use our pipeline. IDEA has another pipeline of their own. I know that some of the big, large-scale projects are working or have their own pipeline already. And this is just because an hour at a terabit per second is going to be a few terabytes. So an hour at 32,000 channels is going to be a few terabytes. So that's not going to fit on your laptop very easily. Overview. This is a bit of stuff. Shows you how you do it. And in case you want to see, I can show you an observation. Oh yes, I had one ready. Continuing image. This is 0.99 hours, so not a full run by any means. And, well, what's in the field? It's actually a number of different fields, but let's have a look at that one. And this is just the image. And there's a neat big swirly galaxy over there, and what looks a bit like a cluster over there. And yeah, interesting stuff. And this is typical quality stuff. This is not specially chosen for anything. And the FITS file is obviously also available, but I'm not going to download that now. Anymore. I had a few more. Hang around, please.
Tony, can I interrupt, please?
Yes, of course.
Hi, this is Chandra here. I have a question regarding the data amount. Like, you say that it's 32K channels, right? So
you can choose that, or you can choose 4K channels, in which case it's smaller.
Right. So if I choose the 32K mode, is it possible to choose the final recording bandwidth to be smaller than what it is? So that, like, I don't want so much.
That's one of the things we're testing out at the moment.
Oh, okay. All right.
I'm not sure I'm allowed to say it, but it should work, but I can't guarantee it yet.
Okay. All right. Thank you.
Yeah.
Yeah. Oh.
The normal mode at the moment is the whole bandwidth, the whole thing, and
the whole bandwidth is pretty big.
Yes, Hercules A was one of the things we wanted to image. And bear in mind, the images will have artifacts of some level. This is the odd radio circles, and I think this was one of them. But anyway, yes. So you can actually see artifacts ringing out from that thing. The worst possible setup is a strong source over towards the edge of the field, because that can really mess you up. Right. Anyway, these are our version of a pipeline. Other people have other versions of a pipeline. I'm not going to say which is better or worse, but you will need to pick one for your project if you're going to reduce it. Right, where was I? UHF status, we don't have all the receivers working yet on that. And you see the interference is actually around a specific bunch of channels here. A little bit there, not too bad. Right, that's all that. I will say though, however, calibrating UHF is actually more tricky because it's a large beam on the sky, which means more sources are in there, so you don't get any isolated point source or even anything like that for calibrating. We've now got a number of calibrators that have actually made a sky model for the calibrator. Seems to work quite well. If you pick anything non-standard, it will be your problem to make the sky model. So there are a bunch of reports. Right. Yes, this was quite nice. Down to the bottom. Yes. That's not the one I was looking for. That's one of these ones. Anyway, not relevant at the moment. Oh yes, it is possible to use snapshots. And one of the people, Tom Mount, tested this out, and he used snapshots of a few minutes each, if I remember rightly, of a number of galaxies around the southern hemisphere. And there's an image of one of them. Now this shows you a problem case where you've got a very strong source off near the edge of the field. But anyway, as I say, you don't need to run a full observation. You can get away with snapshots. Right. Default integration time is 8 seconds. But, yes. And that will give you a terabyte with 32,000 channels in an hour. It's done in a sort of quasi-Gaussian distribution. So you've got a bunch, it goes, as you go further out, they get thinner on the ground. So this is a far out one, all these ones, and this is going towards the center. I'm not going to go through the interactive map. And this gives you some idea of the UV coverage at various different declinations for full tracks. Right. Antennas, the length, of course, as I said, is bigger than its width. And receivers sit on a little receiver indexer here. So you can actually say, if going from one to another, it doesn't take very long, a few minutes. Similarly, because they're small and lightweight, you can actually slew the antenna reasonably fast too. Signal gets digitized up there and goes on fiber optics down to the ground. And this is a man for scale. Yeah? Good. System temperatures, T-sys divided by efficiencies gets you to about 20-something Kelvin. And if you prefer system equivalent flux densities, it's 400 and something Kelvin. The bits blocked out and bits where the interference is really too bad to follow what's going on. Right, shape of primary beam. As you see, you get to quite a sharp null. And then the secondaries are smaller. So the side lobes are not too bad, but they're there. If you're going to have a strong source in the side lobe, it will give you trouble.
Tony,
yes?
Sorry, can I ask one question here? So
yes.
For imaging, how good is the primary beam correction? As in, like, what do you recommend? If I have multiple sources in one beam, and then there are many galaxies at the edge of the beam. So what I can do is, like, I can integrate for 2 hours, 2 beams, or 2 hour 1 beam. Like, you know, I can get all the galaxies in one beam.
I would actually suggest you mosaic the thing.
Okay. All
which
right.
we've done for lots of sources.
Thank you.
I mean, it's up to you. It's not my decision, but that's
right.
Just my
No,
advice.
I just wanted the recommendation from SARAO. Like, you know, what do they suggesting?
Yeah, well, back here, yes. Think about which calibrators you may pick, which are good ones, which are bad ones. Made a list. Where's it gone? Come on. Come on, you should be there. Oh, never mind. Being a bit slow today. Right, so think about calibration strategies and selections, but we do have an observation planning tool which you can use. It'll come up with suggestions of what is a good calibrator nearby. We can, we've got also UV coverage simulators for your source. So if you want to do 2 hours at the start of its rise, you can simulate that. And you can simulate images, and you can make all sorts of useful things. But you will need a login account to do any of these. So if you want to go through and use this stuff and submit a proposal, you have to get into the account. Right? Right. I think that's the guts of what I have to say. So, get the science justification, go to the website, get an account, check the technical feasibility, obviously, decide how you're going to reduce it. There are pipelines, but you'll have to check with them if they're willing to take your stuff. In general, they're very easy, but they need to know in advance what they're dealing with. So, that's the guts of what I wanted to say. And are there any more questions?
Okay. Thanks,
Anybody?
Tony. I think Injay, you mentioned you had a question earlier.
I have already asked.
Oh, that you've already.
I thought you had another
Thank
one.
I asked plenty, I believe. Thank you. Yeah, thank you.
Okay, good. Anybody else willing to speak up?
Tony, hi, it's Chandra again.
Yes.
So there's one thing, is it possible to get this account and do the data analysis there, like instead of like taking the data to the home institute?
It's possible, but the data analysis bit you'll need to ask.
Okay.
Because
all right.
we don't set that up for everybody by default.
Okay, all right.
But in general, they're not being difficult about it, provided it's not too much. So if you ask for 10 hours at 32,000 channels and 2-second integration times, that's a vast amount of data. And there might be a bit of moaning and grumbling about it.
So that 2-second integration time, like that 8-second, what you said was the default.
Yes.
Is it possible to ask them to record at say 16 seconds or higher, or like, you know, if I do not need that kind of resolution?
It's possible. Hold on. No, you'll have to integrate it to yourself.
Okay.
That's not one of the standard modes.
Okay. All right. So I can also collapse channels, right? And then
Yes,
transfer the data.
that, yes. I mean, if you really wanted to, we also have a 1,000 channel mode. If you really, really don't care about frequency resolution, which for some computer stuff is really not that relevant.
No, I would care. I need that 32K mode, but
Okay.
Maybe like 2-channel collapse after that.
Yeah, well, then have to arrange that yourself, I'm afraid. So you have to talk with the people who do the pipelines. So that's either us or IDEA or somebody else who might have a pipeline running.
All right. And just one more question. So your sensitivity calculator, the observing time calculator,
yes.
Does it have the fudge factor included?
It has the factors that we know about included, and it's reasonably accurate for most fields.
Okay. All right.
But
yeah, I was about
the problem is not the sensitivity. Very often, if you go to a very deep image, you start picking up confusion because you pick up more and more weak sources.
Yeah.
So when you're down at the sort of tens of microjansky ranges, you really hit a lot of sources.
Yeah, well, that could be probably, that may not be the situation in our case, because we are not going very deep actually. I mean, we don't intend to, but along the band, the fudge factor may change, right?
Yes, it does. That's why we give them the plots of system equivalent flux density across the band.
Okay, all right, okay. All right,
Just
thank
to give you an idea.
Thank you, thanks for that.
Okay.
Yeah. Yep.
Good.
So actually, actually the 3 questions come to my mind, if I can ask quickly. So one is that technically for the shipping the data, should we just order you know, 10 or 100 terabytes disk, and then SARAO just send by mail to other institutions?
I'm not sure how that's going to work at the moment, but for the stuff that's locally, I know it's all done over the network. I don't know how good the network connection is between us and the UKZN. So we have had people request stuff on large numbers of large disks. but you'll have to check again in advance how you're going to do it.
I see. Also, because there's a lot of overseas institutions applying for time, so
yes,
if that is the channel, then we rely on international courier service, I guess. So okay.
Most of the sites abroad, they've actually set up their own data center that can handle this stuff. So we'll actually send it to there over the fiber.
Oh, I see. I see. The second is for your UHF band.
Yes.
I mean, I can see there's a number of channels. So can that? I mean, this is the image only proposal, but can that also see like special lines or like on just from frequency direction for the interesting source?
I don't know of any strong spectral lines in UHF. I mean, there are always things like recombination lines, but they're extremely weak. I'm not sure why. Oh, if you want to do sort of a highly redshifted H1, you can try it. I know some people are trying that out.
Just add a background information that my friend and I are interested in constraining the axion mass, the dark matter candidate, and
yes,
there is a prediction for that for UHF band spectral line. So if we don't see that, then we can put a strong upper bound for the axion mass, things like this. So I guess we are interested in spectral line observations. And
well, you can have spectral line observations. I would suggest you go through the calculator and see what time it would take. I suspect rather a long time, but in that case, then you just have to say you want to do a pilot study before you go through with full observation.
Yeah.